Cool. All right. So the theme of tonight, obviously, is MCP. I'm going to kick it off by talking about some of the stuff we're doing with MCP. For those who I haven't met, and I recognize a lot of faces here from events we've done, so welcome back if I know you, but welcome for the first time if you're not. So I'm a co-founder of a company called JamSocket along with Taylor. And we've been at it for about 3 years now, building WebSocket infrastructure. So ways to just kind of scale up WebSocket applications. In the course of building that infrastructure, we ended up running a lot of sandboxes. We run millions of sandboxed execution environments a month for our customers. And so one of the things we started to see people do with those is, as ChatGPT came up and LLMs got really good at writing code, people were like, oh, you guys make sandboxes, you can run code generated by an LLM. So for the last little while, I guess since earlier this year, we've been doing Forever VM, which is kind of a more purpose-built product based around untrusted code execution, particularly for LLMs. I'll show you a quick demo because we've got a fun demo on our site. So I'll just go to our site, and it brings up a Python REPL that's running remotely on our cloud. I can get it to do things, import data, load data, draw pictures. This is on Amazon, but none of the infrastructure is really Amazon specific. We can actually, it's built to deploy to other clouds as well. Currently only on Amazon. So go back here. So the thing that I've kind of come to believe about this, that I think is quite relevant to the MCP world, is that code is kind of the ultimate tool call. My kind of heretical belief maybe in this room is that I'm not really excited about like tool discovery as something that agents do, because I think that if agents are able to discover tools, they're just going to be able to write them. I'm going to show a quick demo of something a colleague of mine, Jake, has been working on. This is, so we took our Forever VM execution environment and provided we've got like a little notebook environment where we can provide some environment variables. And he's going to use this to build a web app, basically build a Lambda. I don't know if anybody's used AWS Lambda, but it like makes everything 10 times more complicated than it needs to be. So his prompt is, let's build a simple web app from scratch in my AWS account using Boto 3, create a Lambda function that returns hello world in an H1 tag. And I know the screen's a little bit harder to see, but I'll read it out. So it's, as it always has like a bunch of verbose stuff, we can ignore that. But then it jumps into kind of writing some code. It's writing the code that runs in the Lambda. Then it's going to it's got to create an IAM policy. And it's kind of doing all this pretty quickly. And so it's done this. It says, if you need help testing it, let me know. So he says, create an API gateway to mount it at path hello. So it's doing all this stuff. It's printed out the URL that he can go to. And I've been fast forwarding, but this is about 54 seconds in. So, this is faster than I've ever set up a Lambda. And he goes and, internal server error. So he just does internal server error, frown face. And let's see. It figures out what the issue is, The nice thing I find with like vibe coding is you don't always have to care what the issue is. Like you just like, there's an issue, fix it, I'll come back. So it's adding some Ret 53, But I think somewhere I might have skipped by, somewhere he made it work. There we go. There we go. So he switched tabs very quickly, but if you saw that hello world, yeah. So that worked. So my point there is that, there's people have built AWS tools, tool calls, MCP servers, but there's a lot that they can't do because you kind of often need to poke around and try things that are not in the tool call. They just make raw API calls, and so code provides a nice way to do that. So over the weekend, one of our investors asked me, sent a text and said, can I run Claude Code in Forever VM? And it kind of nerd sniped me because this is something I've wanted to do as well. If you think about kind of a MCP server environment, the way we typically use MCP servers today, it's like this, right? Client could be Claude Code, could be Cursor, could be Windsurf, but your client is usually running kind of on your laptop, on your desktop, physically on your device. And this investor wanted to run like a dozen of these in parallel or more, maybe 100 of these in parallel. Like you kind of have, you can imagine something like go through my stack of Git issues and just throw them into Claude Code and see if it comes up with something. So I think this is sort of a fundamental issue with the MCP ecosystem right now, which is like, what if there is no client? There is no Claude desktop in your scenario. That could be because something is caused by a cron trigger, could be some sort of background task that you want to run, email or Git triggered workflows. In this case, highly parallelized agents, so wanting to run a dozen code agents, 100 code agents, and just kind of general programmatic use of an MCP agent. So something I've been thinking a lot about lately is like, what does a Kubernetes for MCP look like? And this is sort of what I come up with. Like you kind of have like a work queue and some LLM workers and some tool workers. And so I'm going to show you some demos of what this actually, what this looks like. And again, kind of going back to the use case of Claude Code. By the way, turns out Claude Code is like both an MCP server and an MCP client. So I don't know if you've played with it, but if you want to control Claude Code programmatically, you get these nice hooks by running it as an MCP client. So what I have here is a kind of distributed system infrastructure. There's sort of that queue setup that I described. And I'm just going to say, check out this repo and tell me about it. And in this system, I've got these sort of workflows. A workflow is very cheap to create. You kind of just like create new workflow, but each one is effectively a separate file system. And what we use is kind of an incremental distributed file system. So even though it's a whole file, it's a whole Linux file system, it's actually very cheap to clone because you're just kind of cloning a pointer and then it's adding layers on. So I won't get too deep into the technical details, but it's pretty neat because you end up with these kind of forkable file systems is how I think about it, cheaply forkable file systems. So it can do things like check out a repo, and it's going to do that. And so all of these tool calls, these bash, ls, these are tool calls exposed by Claude Code when running as an MCP server. So it's running these in a sandbox and getting the results back. And even though for now this is running on one server, it's all architected so that each of these tool calls could be run on a different server. It's just synchronizing the file system incrementally between them. And that's nice for sort of durability and things like that. And so it's sort of exploring this repo and eventually spits out a nice markdown block that kind of covers all of the, it's kind of a regurgitation of the README, but it does have some things that are not in the README that it's able to kind of use that deeper intelligence to, and use those code tools to discover. And then the second demo is like, can you get it to actually make, write code, because that's what Claude Code is best at. So I tell it to make a hello world program. Turns out there's like a number of bugs in this. This is kind of just, I was working through it today. So it takes a lot longer than it needs to kind of come up with this. I go back and forth to see if anything's broken, but does eventually create a hello world program. So little ways to go to get it as seamless as Claude Code, but the fundamentals here, it's making these MCP tool calls. And I think that this is, just as a fundamental piece, having a Kubernetes for MCP or Kubernetes for agents is quite nice. So we're going to be open sourcing this once it works, and so look out for that. So yeah, forevervm.com, and I'll show this slide at the end as well. So for tonight, I've spoke. We'll have Alex from Keras up next. Is Lily here? Okay, I don't think Lily made it. Sarmad from Last Mile and Andrew from Layer. So speakers, remember your orders. And with that, I'll hand it off to Alex. I'll give you this for the recording as well. Sure. If it turns out, we'll see.
We'll see. Things are always difficult.
Yeah.
Ask you a quick question.
Yeah.
Whatever VM does it work just on a local machine?
It doesn't right now. I would like to. Something needs to be built with like the Mac virtualization framework. I don't know if I'm the one to do that. I've tried getting Claude to do it, and it can get all right. But yeah.
All right. Holding this laptop is awkward, so apologies for gesturing with a MacBook. So, started something new, though my LinkedIn still says Chorus. I am a co-founder at Empathic. We are building an AI native data substrate for the enterprise. Here's some links if you're curious. LinkedIn, Blue Sky, standard things. And I'm going to talk about some questions that have come up in the context of playing with MCP. I don't really have a fancy virtualization platform for these things that you can run MCP on, but I do have some thoughts around what happens when you try to actually get MCP to do stuff. Fundamentally, I think of MCP as an agent's eyes and hands. And like, how do you determine what it can see and touch? Like a lot of the discussion of MCP is very much around like, oh, okay, we plug it into this thing and suddenly it generates code in your directory and whatever. But like, how do you constrain that? How do you choose that? And in the context of millions of agents, lots of parallel agents running in your enterprise environment, how do you prevent it from doing dumb stuff because it doesn't have shame and can just arbitrarily mutate whatever it feels like? And so let's start by thinking through, since I'm dealing with an AI native data substrate, I'm very considerate of what it means to connect to a Postgres database. And today, how you choose the Postgres database you connect to and what it has permissions on is really hard-coded. The Neon, this is a copy from the Neon README for how you actually wire this up to Neon, and you go through an entire process of getting an API key, and then you tell it the API key, and that defines everything before you even run the server. Kind of the same for the like Hello World example. You have a JSON file that has an argument to an NPX call that says, here is my database, and probably your password and everything is wired directly in there. But what if that changes? Okay, they said they're doing OAuth. OAuth is great. I think this is a great evolution. Like, I think Anthropic is doing a good job launching a thing, iterating on it consistently. And I think OAuth is a good fit for lots of the things that MCP is going to interact with. But it doesn't really solve a bunch of the configuration issues. Like, okay, now I can, if I already know what I'm connecting to, I can give authorization when I didn't have authorization before, but how do I know what I'm connecting to in the first place? How do I know who is connecting? How do I know all of these things? And so as an ecosystem, as users of MCP and writers of servers, we have a long road ahead for figuring out answers to these questions. So let's go through a couple informative examples, I think, of why, like where these things might break down. I'll start with this context that to some degree is solved by the OAuth extension of, on the left, you have an agent that is fulfilling customer service role at an airline. And on the right, in yellow, you have you, who's trying to reschedule a flight that's delayed, and the kind of OAuth grants that are littered through this as it doesn't have access permission. So first it says, like, hey, how can I help you? You want to know what your flight status is. It's delayed, or it needs to know information about your flights. You give it read permission. It tells you and says, hey, I could reschedule it because it's delayed and it's been 24 hours since you did it. So you say that would be great. You give it delete and creation permissions, and you fulfill it. That's great. Like, you can do that with the OAuth stuff today that looks like this. This is in the docs as of this week, fundamentally. But this solves the proximate issue. It doesn't really solve the ultimate issue. It says, okay, I'm talking to an OAuth provider service that has this functionality, but at what point am I mutating the database? At what point am I changing the underlying system? And what mediates that? It doesn't really solve that problem. It often pushes problems deeper in your infrastructure, but you still have to think about them. And so as an ecosystem, we need to think about, if we want these things running alongside our other infrastructure, how do we solve these in a consistent and scalable way? Here's another example. So that first one was kind of evolving permissions. And this is a question of capabilities. In the MCP standard, there's a dynamic around when you initialize, you ask the MCP server what it can do. And it gives you a flat listing of all the capabilities it has. But what if your agent starts out as a user that only has a fixed set of capabilities and shouldn't know about what an admin does, and later gets elevated to an admin? What does it mean to gain new capabilities in the context of an existing execution? So those are just some examples that motivate some of these questions that I have here. And I think questions we should all be asking and questions we should all be trying to figure out the answer to around like when an agent comes online, like what does it see? What is its Umwelt? How does it interact with things? What determines the set of permissions it has out of the box? How does that evolve over time? And like what authorization boundaries does it have to interact with? Like how do you expand the capabilities? How does it iterate on this stuff if it is supposed to be an autonomous system? And how do we interact with things that aren't OAuth, that aren't on the web, like Postgres? So I think generally I call this the like discovery and evolution of configuration. So we need to solve configuration, discovery, and evolution, and I think we should all try to figure this out together. So if you want to chat more about this, come talk to me after. I think this is a topic of active discussion in the community. Here are my links again, and that's me. Yeah.
All right, thank you, Alex. Next up, we have Sarmad. I'll give you a mic. That goes on the inside, and then it's magnet.
Can you hear me?
It's just for recording.
Okay. I'll speak with my voice then. Cool. So my name is Sarmad. I'm the co-founder of a company called Last Mile, not to be confused with the last mile questions you had on your slide deck. And we are basically a developer tool company based in New York City, trying to help engineers build AI applications. And so today what I want to talk to you about is this project that I was working on over the Christmas break that's kind of become a real thing called MCP Agent. So it's just a bit of background about me. Weird screenshot, but I worked on language server protocol at Microsoft back in like 2018 and language servers and IDEs. And LSP basically revolutionized how IDEs are built. Because before that, basically like every IDE client had its own way of surfacing language features and APIs for how language server developers would implement those features. And so like a VS Code language server would not work in Atom or Sublime or Notepad++. And so these language server developers had to like implement everything over and over again. And you can imagine that's like not great. And LSP changed all that. It really like revolutionized it. And this is just an illustration of like how many language servers there are that are like implemented on LSP today. Like the scrolling, it's crazy, right? And it's like a revolution. And MCP was inspired by LSP in many ways, and down to like it using JSON RPC as a protocol, how it initializes and requests capabilities is like almost identical to LSP. Also, I've been thinking about a protocol for LLMs for a long time. This is from Jan 2023. It's hard to read, but these are scribbles on my Amazon Basics notepad about a foundation model plugin protocol. And this is back in the day when like LLMs couldn't make tool calls. It was like ChatGPT plugins was the hot new thing, RIP. And so I was thinking of like, how do you register capabilities? How do you authorize? Kind of some of the things that you talked about previously as well. And it looks really silly, like looking back, because we didn't have a lot of the same like nomenclature for how LLM should interact with the world. But some of the things are still correct. Like JSON RPC is what I thought it should be. There should be a client and server abstraction that's separate. Models should like expose their capabilities. Tools should expose theirs. And so suffice it to say, I got really obsessed with MCP when it came out in November. I was like, this is going to be a huge deal. I think it's going to change the industry. And it's still taken me by surprise, just like how quickly that's happened. Like yesterday, I think Sam Altman said that OpenAI is adopting MCP. And so it's basically, right? Like, please clap. This is, it's a huge deal because it means that the industry has a standard way of giving an intelligence engine access to the world around it. And there's a whole set of capabilities that comes out of that. I also played a small part in that, by the way, because the moment the OpenAI Agents SDK came out, I think mine was the third issue that I added called Please Add MCP Support. And as you can tell, there are like 59 likes, so it was the most popular issue there. And so anyway, yeah, you're welcome. So anyway, so all of this is a long-winded way of saying I got really excited by this towards the end of last year. And the first thing that hit me was MCP is not just like a replacement for OpenAPI or like tool calls alone. It's actually a way of giving agentic capabilities a much more structured environment to operate, which means you can build controllable agents in a world where everything is exposed as an MCP server. And so that's what I built. I built this project called MCP Agent, and it's basically like it's a very simple library that lets you build agents with Model Context Protocol. And I don't know if folks remember this, but there was a Building Effective Agents post that came out from Anthropic towards the end of last year as well, which basically went over like a few simple patterns on how to build agents, saying that like we shouldn't overcomplicate the architecture. The LLM is good enough. And so like you connect an LLM to data, to prompts, to tools, and simple workflow patterns. Like this is a chain. This is like a parallel like fan out and fan in aggregation. This is an orchestrator where like there's a planner involved, and then like it decides how to fan out things. And so basically the MCP agent repo is an implementation of that blog post on MCP. And so what you can really do here, I'll go into a brief example. You can basically define an agent, and an agent is pretty simple. It's like an instruction and a set of MCP servers that, it's basically an instruction, which is like a system prompt, and a set of MCP servers that you say this agent has access to. All the like other things around connection management and auth notwithstanding, like that's the interface for this. And then all you do is like you connect it to an LLM. So an agent is model agnostic, but you give it powers like an intelligence layer. It could be like GPT-4, O3, Claude, whatever, what have you. And then there are 3 APIs on it: generate structured, which will like create a Pydantic model, or generate string, which will return a string. And that's it. And you can like combine this in interesting ways. So I have this example for like a workflow orchestrator. And in this case, I basically wanted to grade a student's short story assignment. So I gave it a few agents. I was like, there's a finder agent which can like look up files and URLs. There's a writer agent which can write things to disk. There's a proofreader which is able to review its input and proofread it. A fact checker for factual consistency, and a style enforcer for like checking style adherence. And then I give it a very vague task. I basically say, or a very complicated task. Like load the student's short story from this markdown file, and then generate a report across proofreading, factuality, style adherence. And by the way, for the style adherence, use these APA style guidelines from these URLs. And after you're done, write the report to this markdown file in the same directory as the file you found the student's short story in. And all I do is there's this orchestrator, which is an implementation of the orchestrator like pattern described in this blog post. And I tell it which agents it has access to. And each of the agents has access to MCP servers in return. And then you have a workflow, and it kind of like does a remarkable job generating a plan. It plans it out in a series of steps. It loads the story, and then it like, so the story would be something like this, and then it will produce a graded report with like proofreading feedback, factual consistency, APA style formatting, recommendations. Like it's a pretty, honestly, like I would use this instead of doing it myself at this point. So all that is to say, like this was, I think, like less than, most of this is comments. It's like 50 lines of code, the end-to-end function. The other really cool thing about MCP Agent is it turns anything into an MCP client. And so I can like UV run this application as a Python script, and it's connecting to MCP servers. It's making like LLM calls. It's doing all of that. So it's effectively turned my CLI script into an MCP server. And you can like do this anywhere. You can like build a Streamlit app with it, or you can like anywhere you want to write code, you can kind of deploy MCP now. And so that's, I think, the cool part about building this. It's also getting like really organic traction. I did one Hacker News launch, and we have like 2,000 stars now. So please check it out if you are interested in building agents. And then the last thing I wanted to cover is like what's next. So I did this as a side project because I didn't have meetings that last week of Christmas, so I could code for a change. But now it's like kind of a serious project, and we're doing some interesting things as a team around it. One is exposing agents as MCP servers themselves. So like if you think about agents, they're workflows that you write that have an intelligence layer that can kind of like do interesting stuff. Those should be MCP servers that are like tool calls. So you can do agent/run, you can do pause, resume, etc. And the other thing is it has to be workflow orchestration, which is not something that like MCP has as a primitive today. But a lot of, and today people use them as you pointed out in like Claude or Cursor or like in a local client. But it's not just, agents are not just chatbot applications. They should be async workflows that can pause, resume, wait for human input. And so there's a workflow orchestration layer that needs to be built out. Memory as MCP resources, where like you give an agent history and memory has a tree of memories where there's a user-specific memory, entity memories, agent-specific memories, and so forth. And we're trying to like figure out how to add that into MCP agent as a service. And then the hard problem of evaluation, like how is my agent doing a good job or a bad job? It gets super complicated the more complicated these workflows get. And so we're trying to think of like what evals looks like in the world of MCP agents. So I'd love for you to get involved. It's like been a one-person kind of job so far. It's now been like expanded to the rest of my team, but I think it'll take the whole community, kind of what you were saying earlier, that like we have to build this together because we finally have like a shared protocol that everybody agrees is like the way to go. And so let's make it better. So we're doing a hackathon next week. Would love for folks to join. It's on April 1st, but it's not an April Fool's joke. There will be like drinks and stuff available for sure. You can also find me on Discord. I'm pretty responsive there. And also, we're hiring. So if you want to like do this full time, let me know. Get in touch with me after. Thank you.
And last but not least, make you up for the recording. Just an insights magnet.
Wow, this is fancy. So everyone came prepared with a presentation. I didn't, so apologies for that. But I am going to show off what I consider one of the only real-world use cases of MCP that I've found to date. And that's not too strong of a statement considering it's been around for only about 4 or 5 months and it's been popular for 4 or 5 days. Let's get started here. So I guess let me introduce myself. I'm Andrew and I run a company called Layer. And what we do is we build MCP servers for enterprise clients. So ironically, actually, Neon is a customer of ours. So thanks for presenting that earlier. But yeah, I'm going to jump in here and show you guys how we kind of automatically generate MCP servers using OpenAPI spec or a CLI specification, and set them up. So what we've got here on our platform is a series of OpenAPI API endpoints that we convert into tools. Each of these tools has a respective JSON schema that we parse out of it. This is pretty standard stuff. I'm sure you've seen the OpenAPI JSON converter. And what this enables is if I hop over to Cursor here, let me open that up. So I'm going to be demoing with one of our new customers named Clerk. You can see that I have the Clerk MCP server installed here. And what this enables us to do in the Cursor Composer is I can type something like, please list my Clerk users. And I'm sure you've all seen some flow like this. I'm pasting the bearer auth in directly right now because I'm on a demo version of this and it broke earlier today. But you'll see it calls the respective get user list, which we can see is one of these functions right here that we parsed from the OpenAPI spec. So that's neat, that's cool. Again, that's like kind of a useful feature. It's really not all that useful standalone. And so what I think is the neatest thing is something that everybody who's presented so far has hit on, which is workflows. And so we've hacked together a way to actually support workflows. And I'm going to try and run one and cross my fingers that it doesn't fail. So if we go over here and we take a look at these prompts, we call them prompts because that's the That's the MCP idiomatic way of referring to what a workflow is to some degree. You'll see that this workflow has a bunch of steps. It has a couple local actions. It has some text that it's supposed to turn into a file. It also has, this one doesn't have any specific API tools, but we also support that in the workflows as well. And so if I go back to Cursor and I say, can you please create me a new clerk app? What we'll see here is it should hopefully hit this tool, okay? And it'll run the tool, it will output the workflow, and it'll actually start executing the workflow. So in this case, it's going to create me a new Next.js app. After that, NPM is a really slow package manager, so just give me a second. Okay, well, as you can tell, the files are actually being created, the dependencies are being installed. After that, it's going to ask to install the clerk package. And then, let's see, what's going to happen next? Okay, now it creates the middleware file, right? So I basically told it in this step right here in the workflow to create the middleware file. And then Cursor is responsible for creating that middleware file. Now it's editing the layout file. And we're almost done here, I promise. Let's see. Those are all done. Okay, it seems like it's doing a little bit more. I don't know if I wanted to do that, but I don't have a choice now. Oh. Oh, okay. Can we move on? Okay, cool. So it set up this env file, and now we're going to try running npm run dev. And this is the moment of truth, guys. If this works out, then we have basically successfully set up our clerk app doing, as some would say, vibe coded. Okay? And would you look at that? We have our clerk application doing literally nothing. This works. Thank you. Thank you. This works like 70% of the time. Okay? And that's great for 70% of people, but we want to get that closer to 90, 95%. And so as everyone said, there's still a lot to do. We have to figure out a way to put workflows together so that it's scalable, because doing them one by one is a nightmare, but it's still useful. And at the same time, give enough control so that, our vibe-coded systems can actually build cool stuff. And so that's our presentation. We try and do this for big API clients. If you've got any questions, let me know. All right?